Welcome back, Cloud Architects. In this section, we are going to introduce you to computing resources in Cloud Platform and learn how they are configured in networks. At a high level, Cloud Platform offers three kinds of scalable computing services: Google Compute Engine, or GCE, for raw compute capacity with virtual machines, networks, and disks; Google Container Engine, or GKE, with cluster management for running Docker containers; and App Engine, or GAE, for scalable app hosting. Compute Engine compares with EC2, Container Engine compares with ECS, and App Engine compares with Elastic Beanstalk. Here, we focus on Compute Engine with virtual machines and networks because they are key to running custom apps, especially for lift and shift operations, which are often the first steps you take when migrating to the cloud. For details on all three, see the link here. Compute Engine and EC2 take similar approaches to virtual machines, and almost every type of application runs on them. Compute Engine calls them VM instances, or VMs, and EC2 calls them instances. Both services can install various operating systems, configure RAM, CPUs, and disks, store images and create instances from them, launch and terminate instances on demand, manage instances by console or command line. Both offer predefined instances. GCE calls them machine types. EC2 calls them instance types. Compute Engine also allows you to create custom images with specific numbers of cores and amounts of memory. Both Compute Engine and EC2 provide virtual networks dedicated to your account. They are logically isolated from other virtual networks in the cloud and configurable so you can launch resources, such as VMs, into your networks and either isolate or connect them. Both services support ICMP, TCP, and UDP traffic. However, Compute Engine and EC2 manage VMs and networks a little differently, so it's worth looking at how this is done in both services before adding VMs. Like virtual private clouds, or VPCs, in EC2, you have complete control over your network environment, including subnet creation, IP address selection, and configuration of routing tables and firewall rules. In AWS, VMs are placed in a region and an availability zone. A VPC spans a region with a private IP address range and contains one or more subnets. Each subnet spans a specific availability zone with a subset of the IP range from the VPC. Each instance is added to a subnet and gets a private IP address from its subnet range along with an optional public address. Routing tables enable instances to start the traffic sending process and find their targets. Each route says, for a group of instances sending traffic to a group of destination addresses, send it to a target for routing. When the VPC is created, it creates an entry in a routing table that allows instances to communicate with each other using internal addresses. It also allows you to configure access to external hosts using proxies, gateways, or VPNs. And a set of Network Access Control Lists, or NACLs, and security groups govern which instances can communicate with each other. NACLs protect subnets, and security groups protect instances. In this case, Subnet 1 is public, and Subnet 2 is private, so all instances can connect instances in Subnet 1, but only some instances can contact instances in Subnet 2. Finally, an Internet gateway with an additional route and set of NACLs allows instances to access the Internet. If you want to see instances in other regions using internal addresses, you set up another VPC in that region and peer them.